Scientists may be on the brink of discovering a fifth force of nature. Experts are closing in on potentially identifying a new force after a surprise wobble of a subatomic particle. The tantalizing theory that a fifth force of nature could exist has been given a boost, thanks to unexpected wobbling by a subatomic particle, physicists have revealed. According to current understanding, there are 4 fundamental forces in nature. 3 of these, the electromagnetic force, and the strong and weak nuclear forces, are explained by the standard model of particle physics. However, the model does not explain the other known fundamental force, gravity, or dark matter, a strange and mysterious substance thought to make up about 27% of the universe. Now, researchers have said there could be another, 5th, fundamental force of nature. Dr. Mitesh Patel, from Imperial College London, said, "We're talking about a fifth force because we can't necessarily explain the behavior, in these experiments, with the 4 we know about." The data comes from experiments at the Fermilab US Particle Accelerator facility, which explored how subatomic particles called muons, similar to electrons but about 200 times heavier, move in the magnetic field. Patel says the muons behave a bit like a child's spinning top, rotating around the axis of the magnetic field. However, as the muons move, they wobble. The frequency of that wobble can be predicted by the standard model. But the experimental results from Fermilab do not appear to match those predictions. Professor John Butterworth of University College London, who works on the ATLAS experiment at the Large Hadron Collider, LHC, at CERN, said, "The wobbles are due to the way the muon interacts with a magnetic field. They can be calculated very precisely in the standard model, but that calculation involves quantum loops, with known particles appearing in those loops. If the measurements don't line up with the prediction, that could be a sign that there is some unknown particle appearing in the loops, which could, for example, be the carrier of a fifth force." The findings follow previous work from Fermilab that showed similar results. But Patel said there was a fly in the ointment, noting that between the first results and the new data, uncertainty has increased around the theoretical prediction of the frequency. That, he said, could shift the situation. Maybe what they are seeing is standard scientific thinking, the so-called standard model, Patel said. There are other issues, Butterworth said. If the discrepancy is confirmed, we will be sure there is something new and exciting, but we won't be sure exactly what it is. Ideally, the discrepancy would inform new theoretical ideas that would lead to new predictions, for example, how we might find the particle that carries the new force, if that's what it is. The final confirmation would then be building an experiment to directly discover that particle. The experiments at Fermilab are not the only ones to suggest the possibility of a fifth force. Work at the LHC has also produced tantalizing findings, albeit with a different type of experiment looking at the rate at which muons and electrons are produced as certain particles decay. But Patel, who worked on the LHC experiments, said those results are now less coherent. They are different experiments, measuring different things, and there may or may not be a connection, he said. Butterworth added that the unexpected frequency of the muons wobbles is one of the longest-standing and most significant discrepancies between a measurement and the standard model. The measurement is a great achievement and is very unlikely to be an error now, he said.